Hi everyone, Dave Williamson here. I've been in the lighting industry for nearly 30 years, the last 10 of which have been specifically in signage or predominantly signage. I'm an applications engineer by trade. And today I'm going to talk a little bit about connectors. Really sexy subject, I know, but bear with me. So anyway, I'm sat here today in my home office. So I live in Darlington in the UK, and behind me you might be able to see some Star Wars paraphernalia. I'm a little bit of a Star Wars nut. I've also had a fresh haircut today. This is my coronavirus lockdown haircut, courtesy of my wife. She actually did a reasonable job. Yeah, not too bad. And we're going to talk about connectors, specifically connectors when they're used in exterior signage applications. 9 times out of 10 when we're called to site where someone says they've got a problem with our equipment, whether that be a driver or modules, when we get there, like I said, most of the time it's a connection issue. It's either an electrical connection issue or, moisture has somehow entered the system, through the connectors. And that causes problems, obviously. Today, I'm just going to have a look at the very few connectors that are available, on the market today that are used in signage, and just literally go over the pros and cons of each one. And hopefully, at the end, we can have a discussion about, best practices. Did you like what you saw? Would you like to see more? Do you have any questions? Would you like to challenge me? So we'll leave that to the end. We can have a question and answer session. So let me just stop talking and get on with it. So let's go. Here we have an overview of some of the connectors we're going to discuss today, alongside some of the tools that you would need to utilize them correctly. We're going to go through each type of connector in turn, look at the pros and the cons of each one, and maybe give you some tips on how that connection could be made better, so that you have a more robust, longer lasting system. We're going to start with the oldest type of connection technology available in this lineup, and that is the good old terminal block, terminal strip, chock block, call it whatever you will. You don't see them used in signage very much these days, and for good reason. They are relatively cheap, however. The only thing I would say is that they're not the easiest connection technology to use. First of all, you've got to strip your cable. Now, once you've stripped your cable, you need to place it inside the brass receptacle and make sure you get it so that the cable is underneath the screw. Then, you need to take a screwdriver and screw the screw down onto the cable and secure it between the screw and the brass cylinder. If you get it done correctly, there's nothing wrong with it. Unfortunately, what tends to happen is you can nip the PVC out the cable. Not only that, smaller diameter wires, certainly multi-stranded types, they tend to ride up the side of the screw threads, so you can end up with a poor connection. The other thing is, if these are used in external signs, they corrode very quickly indeed. And if it corrodes, one or two things is going to happen. Eventually you'll get an open circuit, therefore there won't be a electrical contact made any longer. Or more worryingly, you will get high resistance, which will lead to arcing within the connector, with high currents flowing. With high currents come higher temperatures, and these things melt. I've seen quite a few of these melt over the years. Would we recommend to use this in exterior signage applications? Well, I think the answer is quite simply and quite clearly, no, we wouldn't. So let's move on. Here we have the most popular connector that's used in signage these days, and that's the 3M Scotchlok range of gel fill connectors. This particular one is a UR2 connector, that's denoted by the red cap. The other one that you see quite often in signage is its smaller baby brother for smaller diameter wires. That's a UY2, and that one has an orange cap. These units do have a lot of advantages, so we'll go through those first, but there are some drawbacks, and I'll come on to those in a little while. So first of all, what's good about it? Well, it's very compact. So if you've got it in a tight spot in a sign, these are very compact, and they're quite easy to and flexible to use. The second thing is, they come with receptacles for you to push your wires into. So you would take a cable, and you don't have to prepare the end, and you would push it through the receptacle, through the body of the unit until it hits the back of the body. And then you would take another cable and the one you want to connect it to, and you would push that into one of the other receptacles and push that again all the way back to the end of the body. Once those are in place, you would take the correct 3M crimping tool, which applies the correct pressure and, more importantly, even pressure across the unit. So your cables are both in place. You can see that because you can see they're at the back of the body. Then to make the electrical connections, you would then squeeze the unit and the cap would go down, and inside there are some IDC connectors. They're insulation displacement connectors. What do? Well, they do what they say, is they clamp around the PVC insulation of the cable, they cut through it and make electrical contact with the conductors inside. Once done, and done correctly, the cap clicks into place. You can let go of the crimp connector, and that's it. The job's done. The big issue, and the one that I see most of these days, is that the guys who are fitting these either don't have the correct crimping tools, or they just ignore them altogether. And what I've seen a lot of people do is use pliers. Well, pliers don't apply an even pressure, number one. Number two, they don't apply the correct pressure. This crimping tool has been designed to give the correct pressure. And what can happen then if you use pliers, if it's not fully clicked home on both sides over a period of time once installed. So you can switch the sign on in the factory and there's a good enough electrical connection, it works. But then the sign goes out on site and then maybe after days, weeks, months, even years of being operated, i.e. switched on and off, so current flowing and then not flowing and heating up and cooling down, these things can expand and one side of the cap might pop open. If that does happen, there's one of two things will happen. One is you'll lose the connection altogether, so you'll have an open circuit, and that's actually a good thing because the sign will just be switched off and there's no further damage. The worst case scenario, however, is you get a high resistance created between the IDC connector and the wire it's supposedly connected to. In that instance, what can happen is higher currents flow because it's not making such a good contact, so you get arcing, and that high current creates high temperatures, and eventually what happens is these things melt, and I have seen a lot of these things melt, so not such a good thing. All right, on to the bad bits, and I'm going to say something controversial now. We don't recommend these for use with our systems, so not with our drivers, not with our modules, and there's a couple of reasons for that. The first one is these are filled with a mineral oil based grease. A lot of people seem to think it's a silicone gel. It's not. It's a mineral oil based grease, so it never actually cures, it never sets. What can happen once you've got the wires connected, if you've got a module somewhere close to this unit, the mineral oil, so the oil in the grease, can wick along inside the jacket of the cable and make its way into the module. And if it makes its way into the module, then some damage is going to occur. The other thing about these, and the reason we don't recommend them, is 3M developed these for telecommunications applications. They're actually only suitable, according to their own data, for solid single core cables, not for multi-stranded cables. They weren't developed for that. And if you can imagine being developed for telecommunications, they're operating at very, very low currents. We're talking in the order of milliamps, whereas in signage systems, we can have 5 amps up to 20 amps, depending on how many modules you've got connected and how many of these you've got connected in series or parallel. Hence the reason we don't recommend them. Yes, controversial, I know, but let's move on and let's see some of the other systems we would recommend. This is another of the range of the 3M Scotchlok types of connectors. This is a 314 connector. This particular connector is for larger diameter cables, hence being a bigger unit. It'll also handle solid single core as well as multi-stranded cable. It'll also take different diameters of wires in the same unit. You would still need a special tool to make the connection. But again, for all of its pros, unfortunately, we can't recommend this particular unit. And again, for the reasons mentioned before, the biggest one being that this is filled with a mineral oil-based grease. So anything that's close in connection to these connectors in a system, oil could wick and get into the system through the cables. So we don't recommend. So we're going to move on and look at some others. Here's the first in the range of toolless connectors we're going to have a look at. This is a Vargo 222 type connector. It's quite striking in the fact that it's got a grey polycarbonate body and orange levers. This really is a good electrical connection system. All you have to do is strip the cable to a requisite length, put it in the receptacle once the lever's in the upright position, and then once the cable is fully home, you just press the lever down and the electrical connection is made. A very strong connection with very, very good strain relief. Having said that, a couple of issues with it. One, it's a little bit big and bulky for use in signage applications, especially if you're in a particularly small sign. The second thing is that they have no protection against the environment. If there's moisture present in the sign or in the vicinity of where this block's mounted, moisture can get in to the system. So yeah, good try, but not quite there yet. But next up is something that takes the game on a little bit further. Following on from the Vargo 222 connector, here are the Vargo 221 connectors. These are, like I say, a successor to the Vargo 222. They're much more compact in terms of physical size. Not only that, they come with a clear body, which allows you to see the cable within the connector itself to make sure that you've got a good electrical connection. The other good thing about these units, much like the Vargo 222, they come in a 2-way, a 3-way and a 5-way unit, so it makes it fairly flexible. Other pros to do with this unit, it is rated at 20 amps, which is suitable for most signage systems out there. Not only that, and probably more importantly, it's suitable for a range of wire diameters anywhere from 0.2 millimeter all the way up to 4 millimeter in terms of conductor size, and that's both solid single core cable and multi-stranded cable. So a really, really flexible connector. But Dave, I hear you say, well, the Vargo 222, didn't have any sort of moisture protection or protection against environmental factors, and neither does that one. And you're absolutely right, it doesn't. However, a little bit later on, I'm going to show you a neat trick, a tip, if you like, to make these probably one of the best connectors on the market, or one of the best connectors you can use for a robust and reliable connection. So we'll get on to that in a little while, but let's have a look at some other connectors in the meanwhile. Last but not least, in terms of physical connectors to connect two wires together, here we have the soldering connectors. Come in a range of different sizes, one for large diameter cables coming down in size to, really small size cables. The one we're going to take a look at, and the one that's most of interest to us for signage certainly, is the red banded connector. And what this is, it's heat shrink sleeving, and in the middle here with this band, this metal band, inside of the metal band there is solder. And the idea is, what you do is you take your cable, one of the cables that you want to connect, and you push it in to one side of the cable. Then from the other side, you push the other cable, and then you apply heat and you create the electrical connection. These are relatively new kids on the block, even though they have been around for a number of years. If done correctly, following the correct procedure and everything else, they can make an excellent, electrical connection with good strain relief and good moisture resistance. The only problem with this is it's quite fiddly, it's quite time consuming, so it might not be the most economical way to do things. But I'll show you how that's done a little bit later on. Let's have a look and see how we use a soldering connector. I have the two cables that I want to connect together. I have a soldering connector itself, and I have some heat shrink sleeving. What I'm going to do is put one of the cables in through the connector, and I'm going to have it so it's about halfway through, or the stripped part of the cable is about halfway through the connector, a bit like this. What I'm going to then do is use a gas solder torch, or the heat from a gas solder torch, to heat up this end. You can use any other type of heat gun, but don't use a naked flame. And what I'm going to do is I'm going to gently put the heat into this side, and what you'll see is the sleeving starts to shrink around the cable. All right, so we've got that. Take the heat away, and what you should be able to see now is that the heat shrink is now shrunk, and it's now gripped hold of the cable. Therefore, what I'll then do is put the other cable that I want to connect in through the other side, push it through, and again about halfway through the soldering with the stripped cable end. Take my heat again and apply the heat to this side, so the heat shrink shrinks around the cable and grips it. All right, and that's about enough. So what we have now is two cables, which are both gripped at either end. But what you'll see is the connection hasn't been made yet because we haven't put any heat on the soldering. So what we'll do is we'll put some heat into the solder ring. And there we have it. The solder is now melted. And once that cools down, what we have is a very, very good electrical connection. But not only that, we have very, very good strain relief. But we wouldn't leave it like that. We would take a piece of heat shrink sleeving and put a bit of secondary protection across the joint that we've just created. So we put that across the middle. We'll take our heat again and use the heat to shrink the heat shrink around the connection that we just made. And now we have a good solid connection, good strain relief, good moisture resistance, and a perfectly good joint. I told you earlier that the Vargo 221 connector, due to its compact size and its ease of use without any tools, was an excellent electrical connector. However, it wasn't really suitable as it comes out of the box for use in exterior signage. There's a great tip that I actually got. It wasn't thought up by myself. I saw this in another workshop. To be able to make this moisture proof, so suitable for use in exterior signage. It's really, really simple. You take some electrical grade silicone. I just happen to have here some Dow Corning 3140. Other manufacturers and other types are available and perfectly acceptable. What I've done is I've cut the tip to the right size, to fit the receptacles on the Vargo 221. And all I'm going to do, and hopefully I can show it here, is push the tip into the Vargo 221 connector, squeeze, and you can see the silicone going in. I want to see it come out of the test hole at the back. And there it is. And I can remove that and do exactly the same for the other side of the connector. Squeeze it in, you can see the silicone going in, make it all the way to the back, and then I can take it out. Here's the wire that I prepared, so I've stripped it to the requisite length. I just push that into the connector. I can see it's made it all the way to the back, and then all I do is close it, and that is the connection made. Now, the silicone that's used is obviously flowable, and it will cure in probably 5 to 10 hours, depending on temperature and humidity. But once that goes off, it doesn't go rigid, it remains flexible with the cable and it grips to it. Therefore, it will provide an excellent moisture seal. Here's, I'm going to show you one I've made earlier. Oh, and here it is. The silicone is now cured, and what you can see is it actually moves really, really well. You know, if I move the cable relative to the connector, you can see it's, you know, the whole thing is encapsulated. The only thing I would recommend, and I know it's probably it's not that valuable, but you know, good practice would say that you would mount in this orientation with the cables facing down over. The reason being is there's less chance of moisture getting in to the top than there is through the bottom. But you know, with full of silicone, it shouldn't really matter. But that makes an excellent system. So you've got a really good electrical connection, you've got really good strain relief, and you've got really good moisture protection. So I would thoroughly recommend this method of making connectors. Well, I've shown you how to connect two wires using connectors, terminal blocks, and even solder rings. There is an old school way of doing it, and that's just to twist the wires together and solder them. So let's have a look at that. So here we go. I've got my two stripped cables. What I tend to do when I'm doing it is I put them across each other in an X formation, around about halfway through the strip length. I then twist them together, like so, and nice and tight. And what you end up with is two wires twisted together. But obviously that's not the end of it. What you would then do is you would take your gas soldering iron, you would tin the tip of the solder, you would place the solder and actually touch it up underneath the two twisted cables, and then bring the solder down from the top. So you've got your solder here, you put it underneath the cables, you then melt the cable from the top, and there we have it. We have a lovely soldered joint. All right, we'll take the heat away. Again, that's not finished. I wouldn't leave that exposed in the sign. So again, we'll take a piece of our old friend, the heat shrink, and then I'll just place that across the joint. So here we have our heat shrink cable. Make sure it's across the joint. Get the heat from the soldering iron. Gently heat it up. So now, not only do we have a very good electrical connection with excellent strain relief, it's also now pretty much moisture proof as well. There we have it, thoroughly recommended. Cheap and easy, takes a little bit of skill to get used to, but once you get used to it, a really solid connection. Well, I've shown a few examples of how you make connections using terminal blocks and you know, the like. What about the module at the end of the run? You know, that is another place where, you know, moisture can enter the system. So what can you do? So here we have a module, and there's two ways you can do it. One would be you would place, you know, a connector, you know, with some RTV electrical grade silicone, you know, on the end of each cable separately, you know, to finish the end of the run. But the easiest and cheapest and quickest way to, you know, seal the system is if you cut the cables on the last module, you know, as close to the body as you possibly can, and then take your old friend, the electrical grade silicone, which I have here. What I'd recommend is you basically just dab the electrical grade silicone onto the ends of the wires, and when that cures, you will have a moisture proof connection, so no moisture will get through. You know, that's that covering. And just to show one that has already been already been done, I did this one yesterday, so this one's now fully cured, and this is now a fully moisture proof end of run connection. So fantastic way, an easy and cheap way of making sure that moisture doesn't enter the system. All right, well, you've listened to me drone on about connections, how to make connections, etc., to make them electrically secure, to make sure moisture doesn't get in. Well, why have I been banging on about this, through this session? Well, the fact of the matter is that moisture getting into the system is a big issue. And I'm just going to show you an example of it here. If I show you this PCB board, this is from one of our own modules, what you'll see is this LED is almost completely obliterated. The one in the middle here is starting to show signs of damage, and this one's yet to show any signs of damage. But what you can see, if you look very closely, you can see some green galvanic corrosion, and that's moisture. Now you might just think, well, that's been sat underneath the lens and it's leaked, the moisture's come in through the lens, but that's actually not the case. The moisture hasn't come in through the lens. It's actually come in through the IDC connector. So we use IDC connectors to make the electrical connections in the back of our modules. This gives us some advantages in terms of, loading and, strain relief. We don't have, any issues with those. The problem is that if you have any external moisture present and you haven't capped the wires or made a suitable electrical connection, moisture can enter the system through the cable. And what you can see quite clearly here is there's no moisture at any of the points where the cable would enter the module through the moulding. All of the galvanic corrosion is based around about the IDC connector, and it's actually the positive side of the connector we can see here. So these things obviously heat up and cool down, when they're switched on and off. And what can happen if there's any moisture outside, because the module body is so impervious to water, they're really well sealed against moisture. If water can find a way in, it will, and it'll take the path of least resistance. And usually, if there's a poor connection or there's a cut end and it hasn't been sealed, water, if it's present, will travel along that cable. And this is an IDC connector, so it actually pierces the outside of the PVC jacket of the cable. That will allow any moisture that is present there, because it's wicked along the cable, to come out in the module, because the water wants to find the hottest point of the module itself. And what happens is the water comes in because this module is warm, and it finds its way to the hottest point on the PCB. And usually the hottest point on the PCB is where the junction of the LED is, where the slug of the SMD package is sat on the PCB. And you can see that all of the galvanic corrosion, that greenish stuff here, is all around the LED itself. So hence the reason why it's very important to seal the system from moisture getting in. That's what can happen. Here I'm just hooking up an experiment, a very simple experiment, to show how moisture, water can move within an electrical system, pretty much under the power of expansion and contraction, heating up and cooling down. So what I have here is some 24 volt Tetra Minimax modules. They've just got standard cut ends, there's no protection on them whatsoever. Here I have some water, and in there is just a red food dye. And what I'm going to do is I'm going to put the end of the cables into the water with the food dye, and then what I'm going to do is I'm going to switch it on, leave it on for a few hours, then switch it off for a few hours and repeat on a regular basis. And we'll see what happens. After a couple of days of a short accelerated test with the dye in the water and switching the modules on and off, 2 hours on, 2 hours off roughly, you can see that the water has already entered the first module. You can see this with the red dye underneath the lens. What I'll do next is I'll open up the module and show you where the moisture or the water is coming from. Here we have the module cut open. You can see quite clearly the red dye is centered around the IDC connectors, in particular the positive connector. This just proves that the system is only as good as its weakest point. Therefore, any connections or any cut cables should be sealed to prevent moisture from getting in. Moisture can travel, probably a metre or so in this manner. So sealing the system is really, really important.